Hello everyone and welcome to day 42 of the low-level design course. Today we are diving into a crucial aspect of system design that ensures our systems are both reliable and maintainable: testing. Specifically, we'll be focusing on unit testing, mocking, and test-driven development (TDD). These techniques are vital for writing clean, robust, and error-free code. By the end of this session, you will have the tools to integrate testing effectively into your low-level design process. Let's get started. In low-level design, it's essential to verify that each individual component of our system works correctly in isolation. This is where testing comes into play. Testing in LLD ensures that the system behaves as expected and helps identify potential issues early, which is critical for maintainability. The types of tests we focus on today include unit testing, which verifies individual components like methods or classes, integration testing, which checks how components interact, and system testing, which tests the entire system as a whole. However, our primary focus will be on unit testing and mocking because these are the most foundational techniques for validating the design at a granular level. Let's dive into unit testing, a fundamental part of testing that focuses on testing the smallest units of your code in isolation. A unit could be a single function or method, and testing it ensures it performs as expected. The process for unit testing follows a basic structure, often referred to as arrange, act, assert. First, you arrange by setting up the necessary inputs or preconditions. Then you act by calling the method or functionality being tested. Finally, you assert to verify that the output matches the expected result. This simple yet powerful structure ensures that your tests are consistent and easy to understand. Now let's talk about some best practices for writing effective unit tests. Tests should be independent from each other, meaning that one test result should not depend on another. They should also be fast so they can run frequently without slowing down development. Tests should be maintainable and readable, meaning they should clearly express the intent of what is being tested. Lastly, tests should be written with the future in mind, allowing them to easily adapt to changes in the code base. To make unit testing easier, we rely on testing framework. These frameworks help structure your tests, provide pre-built assertions, and manage test execution. Some of the most commonly used frameworks are JUnit for Java, NUnit for C Sharp, PyTest for Python, and Jest for JavaScript. These frameworks allow you to automate your testing process, making it faster and more efficient. Setting up a testing framework involves configuring the necessary environment, installing the framework, and organizing your test cases into classes or methods that match the structure of your application. For instance, when using JUnit, you would create test methods annotated with @test, and within this method, you would use assertions like assert equals to verify expected outcomes. By structuring your tests this way, you gain consistency and ease of use, which is essential for large-scale testing. Now let's talk about mocking. In real-world applications, systems often rely on external components like databases, file systems, or third-party APIs. However, these external systems can introduce complexity and slow down our tests. This is where mocking comes in. Mocking allows you to simulate the behavior of these external dependencies so you can focus on testing the logic of your unit without worrying about interacting with external systems. Imagine you are testing a payment processing feature in an e-commerce system. Rather than connecting to an actual payment gateway, you can mock the payment service to simulate a successful or failed transaction. This makes your tests run faster, more predictably, and independent of external factors. Some popular mocking frameworks include Mockito for Java, UnitTest.mock for Python, and Mocha or Chai for JavaScript. Next, let's explore test-driven development (TDD), a powerful design approach where you write tests before you even write the actual code. It may sound counterintuitive at first, but TDD encourages you to focus on the requirements of your code and ensures that each feature you implement is testable. The TDD process follows a simple but effective cycle: red, green, and refactor. In the red phase, you write a test that will fail because you haven't implemented the functionality yet. In the green phase, you write just enough code to pass the test. In the refactor phase, you clean up the code, making it more efficient or readable while ensuring the test still passes. This cycle helps you maintain high code quality and write code that's easy to test and maintain. The TDD helps reduce defects as it forces you to think about functionality and edge cases before you even begin coding. Let's see how TDD can be applied in a real-world example. Consider a parking lot system. The system might need functionality like allocating parking spaces or tracking available slots. Using TDD, we would write unit tests for these features. For example, a test might verify that a parking space is correctly allocated when a vehicle enters the lot. Initially, the test will fail since we haven't implemented the code to allocate the space. In the next step, we implement just enough code to make the test pass, such as creating a parking lot class with a method allocate space. Finally, we refactor the code to improve its structure and readability, ensuring that it remains efficient and easy to maintain. While testing is invaluable, it comes with its challenges. One of the biggest hurdles is testing legacy code. Legacy systems are often complex, not written with testing in mind, and difficult to modify. Another challenge is managing complex dependencies. For instance, when you need to test a system that interacts with multiple external services, it becomes difficult to isolate components. Edge cases also present challenges as they might require significant effort to cover all possible scenarios. However, these challenges aren't insurmountable. You can refactor legacy code to make it more testable, use mocking to simulate complex dependencies, and write tests that focus on handling edge cases effectively. The key to embrace testing as a critical part of the design process. To make testing more efficient, we rely on tools and techniques that can automate and streamline the process. Test coverage tools such as JCoco, Coveralls, and CodeCov provide visibility into which parts of your code are well tested and which are not, allowing you to focus on untested areas. Additionally, continuous integration tools like Jenkins, Travis CI, and GitHub Actions can automatically run your tests each time you commit code, ensuring that issues are caught early. Finally, automated testing tools can ensure that your tests are executed consistently, which is especially important in agile development where code changes frequently. By integrating these tools into your workflow, you can maintain high quality code with minimal manual effort. Now it's time for some hands-on practice. Your task is to write unit tests for the parking lot system. Focus on key features such as allocating parking spaces and tracking availability. You should also mock any dependencies such as payment systems or notifications to ensure your tests are focused on the core functionality. Remember to follow the TDD cycle. First, write tests for the desired functionality, then implement just enough code to pass those tests, and finally refactor your code to improve quality while keeping the tests passing. To conclude today's session, let's quickly recap what we have learned. We explored the importance of unit testing, mocking, and test-driven development (TDD) in low-level design. These practices help ensure that your code is reliable, maintainable, and scalable. Testing may seem like an added task, but it's actually an investment in long-term code quality. I encourage you all to practice writing tests for your own designs and integrate these testing principles into your daily coding routines. Now let's open the floor for any questions you might have. Feel free to ask anything about any today's topic. Thank you for your attention.